Today we're going to talk about the law of conservation of energy. The law states that the total amount of energy always stays the same. This includes mechanical and non-mechanical forms. So let's discuss that. Mechanical and non-mechanical. Well, so far in our class, we have been talking about mechanical forms. Okay, we started out talking about potential energies, energies that were stored, either elastic energies that could be stored in things like a rubber band or a spring, or gravitational potential energy, which is stored and you gain more of it by moving up further from the height of zero level. Okay, then we started talking about kinetic energy, and again, kinetic means moving, so it's the energy of items that were moving. Okay, but those aren't the only types of energies. There's also non-mechanical energy. It includes thermal energy, acoustic energy, nuclear energy, electric energy, and more. Okay, so when we're talking about conservation of energy, we're saying that the energy, the total amount of energy in all these different forms is going to remain constant. Okay? However, in this class, we're going to focus on mechanical energy a little bit longer. Okay? And we say mechanical energy is conserved when there is no friction. Okay? If there's no friction, then if you simply take up your potential energies and your kinetic energy and you add it all up, it's always going to add up to the same thing. It's going to remain constant. Okay? So, let's go ahead and take a look at this in the form of a roller coaster. Okay? So, you get up to the top of the roller coaster, it pulled you up, okay, then you're up the top, and you come down nice big hill, and then go back up a little bit of a smaller hill, okay? So we're going to look at some energies along this route. So you're starting up here at the top, okay? At the very top, your potential energy, we're going to use some nice round numbers, okay? We're going to say you've got 100 joules of potential energy, okay? Now, right up here before you start heading down, you're not going to have any kinetic energy. You haven't started moving yet. You're just kind of up there waiting. Okay? Then you come down, you get down to the bottom. At the very bottom here, okay, this is our height is zero level. Okay? So now all of your potential energy is gone because you're at the height of zero, so you have 0 joules of potential energy. And all of that potential energy has been converted into kinetic energy. So now you've got 100 joules of kinetic energy. Okay? But then you continue moving along and you go up the next hill. This one's a little bit lower than the first. Okay? As you go up, some of that kinetic energy turns back into potential energy because you are above height of zero. So some of that kinetic energy is now potential energy. Let's say, I don't know, 60 joules of it goes back into potential energy, which means that you've got 40 joules of kinetic energy because, again, mechanical energy is going to be conserved when there is no friction. For right now, we're pretending like there's no friction. Okay? So at all of these, the total amount of energy adds up to 100. Okay? At each situation. Now, we know there are times when there's friction. In this example, there would be friction. So let's go ahead and take a look at that situation. All right, we're going to start at the top again. Friction isn't doing anything quite yet because, well, we haven't gone anywhere. Okay? So we've got potential energy of 100, kinetic energy of 0 joules. The roller coaster comes down. As it comes down, there's going to be friction. What is that friction going to be? What types of energy is it going to turn into? Well, thermal energy or heat, and sound or acoustic. Okay, so now at the bottom again, we're at the height is 0, so your potential energy is 0. Okay, and then you've got this 100 joules that's been converted into a few different types of energy. Okay, say 80 joules of kinetic energy. That means there's 20 joules left for the heat and the sound. So let's say 15 joules becomes heat and 5 joules becomes sound. Again, they add up to a total of 100 joules worth of energy. Then the roller coaster continues to move along. Okay, potential energy, well, we're back above height is 0. Okay, so that's gone up. So we're now saying we're at 60 joules there. Okay. Kinetic energy, maybe it's going to have dropped a little bit. So let's say you've only got 10 joules of kinetic energy. So now I've got 30 joules left. Okay, and that's going to be divided among the heat and the sound. Okay, so maybe I've got 20 joules of heat and 10 joules of sound. And again, this is going to add up to a total of 100 joules because energy is conserved. Total energy is conserved always. Mechanical energy is going to be conserved when there is no friction.